This is Ordinary Giants, where the biggest ideas in tech get made simple. Today, we're breaking down the quantum chip that just did the impossible. Let's dive in. Okay, so Google built a chip that just did a calculation in 5 minutes. Sounds ordinary until you hear how long the world's fastest supercomputer would need to do the exact same thing. 10 septillion years. That is a 1, followed by 25 zeros. Here is what you need to know. This is Willow, Google's newest quantum computing chip, and it just crossed a line that scientists have been chasing for almost 30 years. So first, why is quantum computing even a big deal? A normal computer uses bits, ones and zeros. A quantum computer uses qubits, which can be a 1, a 0, or a strange blend of both at the same time. That lets it explore a whole mountain of possibilities at once. The problem? Qubits are incredibly fragile. A stray vibration, a tiny bit of heat, and they glitch. They make errors constantly, and that has been the wall blocking quantum computers for decades. The fix is called error correction. You take a bunch of fragile physical qubits and bundle them together into one more reliable qubit, so they can catch and fix each other's mistakes. But here's the cruel catch that has haunted this whole field. Every time you added more qubits to help, you also added more places for errors to happen. So scaling up usually made things worse, not better. And that is exactly what Willow just broke. Google scaled its grid of qubits up from a 3x3 to a 5x5 to a 7x7. And for the first time ever, each time they made it bigger, the error rate got cut roughly in half. More qubits, fewer errors. Scientists call this being below threshold, and it is basically the holy grail. It's the proof that a real, error-corrected quantum computer can actually scale up instead of just falling apart. And it does this correction in real time, running almost 1 million error correction cycles every single second. Now, the headline that broke the internet. Willow ran a benchmark called random circuit sampling in under 5 minutes. The fastest supercomputer on Earth would need 10 septillion years. That is longer than the universe has even existed, by a lot. The chip itself has 105 qubits, and it has to be kept colder than the empty space between the stars. Now, big honesty moment, because this is where the hype tends to sprint way ahead of reality. That 5 minutes versus forever benchmark. It's a test specifically designed to be brutal for a normal computer and easy for a quantum one. It is not a useful task. Nobody actually needs its answer. In fact, Google says it plainly. To this day, no quantum computer has beaten a regular supercomputer on a genuinely useful, real-world problem. Not yet. So Willow is not a quantum computer that's about to show up in your laptop. It is a research milestone. But it might be the most important one yet. Because the one thing everybody doubted, that error correction could actually scale, Willow just showed that it can. And Google has a whole roadmap from here. If this keeps going, we are talking about machines that could design new medicines, new batteries, and new materials by simulating nature directly. Things today's computers simply cannot do. That's the real prize. Not a flashy benchmark, but a tool that could rewrite chemistry, energy, and medicine. So no, the quantum revolution is not here yet, but Willow just proved the road actually leads somewhere, and that changes everything. That's the story. And that's the breakdown. If this made it finally click, hit that like and subscribe button and drop a comment with what you want me to explain next. See you with another video soon. Until then, stay curious.